This really ties into today's lesson, section 1.6, graphing functions. And I just want you to look at the directions that we had when we worked on this. There it goes, I just lost it. What page again? How'd that happen? Okay, let's go there again. So, when you guys were working on these exercises, the directions here at the bottom say in exercises 27 to 34, you want to do two things. And I want to read this to you so you know what we're talking about. It says, find f of 0 and solve f of x equals 0. Okay? So that's two different things. When we say find f of 0, that's different from the directions that say solve f of x equals 0. Two different things. Okay? Now, I want you to remember this about functions. We're talking about input and output, right? When I say find f of 0, this means that 0 is the what? How do you know? Yeah? Where do you find the inputs in a function notation? It's whatever's inside the parentheses, right? So this is really 0 being the input. All right? So now just again, to use number 30 as an example, what's the function? The function is x squared minus x minus 12? Minus 12, okay? So when they say find f of 0, I like to have the function written down, and then directly below it I'm going to put the 0 in for the input, right? F of 0 is, well, that means everywhere there's an x, I'm going to write a 0. So let's do that. 0 squared minus 0 minus 12. And that equals negative 12, okay? By the way, this is one of my favorite things to do when I have to graph. Suppose I said, graph this function. I mean, is that something you guys would know how to do? How to graph that function? Well, one thing you can do is you can choose inputs and outputs. But it's very nice to make 0 be the input, because that's easy, right? Almost everything cancels out. You get negative 12 very quickly, all right? So if I were to start graphing this one, right away I could say, well, 0, negative 12. By the way, that has a name also. What intercept am I looking for when I do this? That's the y-intercept, right? Because if x is the input, then we're finding the y-intercept. And so, you know, somewhere down here, I don't know, I'd have to scale it correctly, but somewhere down here is the point 0, negative 12. I'm starting graphing. Finding f of 0 is finding the y-intercept. And there's only going to be one y-intercept, because it's a function. It has to meet the vertical line test. If you had 2, it wouldn't be a function anymore, right? Okay, now this is different. When we say solve f of x equals 0, what does this mean? This means 0 is the what? The output. In other words, what kind of intercepts am I trying to find? X-intercepts. And there can be more than one x-intercept. Okay? You guys have questions so far? So here I'm making 0 the output. And so how do you do that? Well, let me do it the same way I just did. I'll write the function down. F of x equals x squared minus x minus 12. But see, the equation is f of x equals 0, right? So this is now replaced by 0. And I get 0 equals x squared minus x minus 12. Okay? So here's a quick question for you. What's easier, finding inputs? No. Finding y-intercepts, which is the first thing I did, or finding x-intercepts? Which one's easier? Y-intercepts are easy for functions, because you already have y equals, all the other stuff's got away. Can you do this? Can you find x-intercepts? Well, I guess you could probably find these. How? Factoring is a great way to find x-intercepts. What if the factoring doesn't work? For this kind of problem, we could do a quadratic formula. Are there other things I could put here set equal to 0 that you'd have trouble with? Absolutely. Okay? X-intercepts can be harder. But this one works out at factors. How? Well, let's see. It's x times x. What factors of 12 do I want? I guess I want minus 4 and plus 3 to get that minus x. So that works out pretty nice. And so, you know, x minus 4 equals 0 would give me x equals 4, or x plus 3 equals 0 would give me x equals negative 3. So these are the solutions to the equation f of x equals 0. On the graph, these are the what? The x-intercepts, right? So I could plot those right now. I could say, well, over here I have 4 comma 0. And over here I have, let's see, 1, 2, negative 3 comma 0. Now, that is the start of a graph. I have 3 points. Now, I could find more by plotting points. As we move through the course, we're going to learn more and more what different functions look like. I started with this example because you know what that function looks like, I think, from previous course. What is that? Okay. Well, yeah, it's not a perfect square, but you could do completing the square like I demonstrated on the side board. But what shape is it going to be? It's a parabola. If it's a degree 2 polynomial, that's a parabola. Okay. Does this parabola open upward or downward? You can actually kind of see it, the beginnings of what it looks like. Right? I'm not going to do any more right now, okay, for graphing. But I at least wanted to get you this example so that you learn the terminology. And by the way, there's a name here that we're going to see in section 6. When we work on homework, we start section 6, work on that homework for tomorrow. These things, these two numbers here, 4 and negative 3, remember, those are the x-intercepts graphically. But they have a name. They are called the zeros of the function. And so tonight on the homework, they're going to say, find the zeros of this function if you can. Well, you're going to be setting what equal to 0, the input or the output? We set the output equal to 0 if it says find the zeros. Guys follow? Okay. I think I want to move on and do 2 more examples with you.